Welcome to today's lesson, Graphs of Logarithmic Functions. Now during your Desmos exploration, you should have noticed that logarithmic functions and exponential functions are inverses of each other. And so an easy way to graph a logarithmic function is to first make a table for its equivalent inverse exponential function, and then swap the x's and y's to plot your logarithmic function. So for part A, f of x equals log base 2 of x, we're going to first make a table of values for 2 to the x. And we'll plug in -2, -1, 0, 1, and 2. This gives us 1/4, 1/2, 1, 2, and 4. Now we're not going to bother to plot these points. We're just going to swap the x's and the y's so that now we will have a table of values for log base 2 of x. So we'll have 1/4, 1/2, 1, 2, and 4, -2, -1, 0, 1, and 2. So we'll plot these points. So notice that we are never going to cross the line x equals 0. So that makes this a vertical asymptote, which also means then for the domain, x has got to be greater than 0, but our range now is all real numbers. We're going to do the same thing for part B, but this time we're going to do f of x is equal to the negative natural log of x plus 3. Now this is a little more complicated because the inverse exponential function for natural log is e to the x, and this also has some transformations. But that's okay. First we'll make our table for y equals e to the x. And we're just going to have to be a little rough with our numbers. -2, -1, 0, 1, and 2. Now e to the 0 has to be 1. We know that e is approximately equal to 2.7. So when x equals 1, we'll graph 2.7. E squared is about 7.4. E to the -1 is about 1/3. And e to the -2 is about 1/8. We're not going to plot these points. We're going to swap the x's and y's so that we can graph our parent graph y equals natural log of x. So we have 1/8, 1/3, 1, 2.7, 7.4, -2, -1, 0, 1, and 2. So go ahead and graph the parent graph. So we have a point here, here, here. This is about 2.7, 7.4. And this is our parent graph, y is equal to the natural log of x. Notice it has the same shape as a logarithmic graph, and because there have been no shifts, its vertical asymptote is x equals 0. So the next thing we're going to do is we're going to account for the negative. Now a negative in front of the function means we're going to reflect over the x-axis. So we'll make our table where we'll replace all of our y values with opposites. So we have 1/8, +2, 1/3, +1, 1, 0, 2.7, -1, and 7.4, -2. And we're going to plot those points. So this is y is equal to the negative natural log of x. And then finally, we're going to take into account the +3. Well, the +3 inside the function means we're going to shift every point to the left by 3 units. So if I make a table for this, I have y equals negative natural log of x plus 3. So my y values are going to stay the same, but I'm going to subtract 3 from all of my x values. So this becomes -2 and 7/8. This becomes -2 and 2/3. This becomes -2. This becomes -0.3, and this becomes -4.4. So I'm just going to plot those points. And here's our final graph. Y equals the negative natural log of x plus 3. Notice that our vertical asymptote has now moved to the line x equals -3. So that means that our domain is x has to be greater than -3, but our range is still all real numbers. Example 2, state the domain, range, and the vertical asymptote of f of x equals the negative natural log of 3x plus 9 minus 7. Before we can do anything, we need to factor out the 3 from 3x plus 9, which leaves us with an equation that looks like this. Now we know that the negative cause a reflection over the x-axis, which has no effect on the domain or the range. 3 in the front gives us a horizontal shrink of 3. Again, doesn't affect the domain or range. Plus 3 inside the function means we are shifting left 3 units. This does affect the domain. And then finally the minus 7 says we are shifting down 7 units. So even though we start with a graph that looks like this, we reflect it over the y-axis, we move it 3 units to the left, and then finally 7 units down. The only thing that affects the domain and range is the fact that our vertical asymptote moved from x equals 0 to x equals negative 3. That means that the domain is x has to be greater than negative 3, and the range is all real numbers. Example 3, state the domain, range, x and y intercepts if they exist for f of x equals log base 4 of x minus 1. So we know the minus 1 inside the function means we shift right, and the plus 1 means that we shift up. But the only thing that's going to affect our domain is that shifting right. That means if we shift right by 1, that means that our vertical asymptote has to be x equals 1, which means our domain is x has to be greater than 1. Our range is still all real numbers. And then we're just going to use our algebra skills to locate the x and y intercepts. We know that the x-intercept is when y is equal to 0. So I'm going to replace f of x with 0. 0 equals log base 4 of x minus 1 plus 1. I'll subtract 1 from both sides. Now I need to write this as an exponential equation, so I'm going to slide the base and drop the log, and I get 4 to the negative 1 is equal to x minus 1. 4 to the negative 1 is 1/4. If I add 1 to both sides, I get x is equal to 1 and 1/4. So the x-intercept is the point 1 and 1/4 and 0. Now we know that the y-intercept is when x equals 0. So I'm going to plug in a 0 for x, and I get y equals log base 4 of 0 minus 1 plus 1, or y equals log base 4 of negative 1 plus 1. Well, we know we cannot take the log of a negative number, so this number does not exist. If this number does not exist, then there is no y-intercept. That's all for now. Thanks for watching.